Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this problem, we're given information about a coil, and we want to figure out what the current through the coil is if we know the maximum amount of torque on it. So, we learned from our book that the amount of torque acting on a coil in a magnetic field is given by the number of turns in that coil, the current going through that coil, the surface area that the coil makes, the magnetic field that the coil is in, and multiply that by sine of phi, or the angle between the normal of our coil area and between the normal to our coil area and the magnetic field. So we're told in this problem what the maximum torque that this coil experiences. Well, the maximum torque, if we look at this expression, the torque maximum is going to occur when phi is equal to 90 degrees, right? Because if phi is 90 degrees, then sine of phi, which is sine of 90 degrees, is 1. And remember, our sine function can vary from 0 to 1. So if we want our torque value to be the largest it can be, we want our sine phi value to be the largest it can be, right? So we're going to get an expression for the maximum torque that this coil is going to feel when we have a phi of 90 degrees plugged into sine, and that just means that's going to go to 1, and we have an expression of NIAB that gives us the maximum torque the coil experiences. In this particular problem, we're given the maximum torque, the number of turns in the coil, the surface area of our coil, and the magnetic field that the coil is in, and we're asked to find how much current is going through that coil. So we do some algebra, see that the current is given by the maximum torque divided by the number of turns, the surface area of our coil, and the cross-sectional surface area of our coil, I should say, divided by the magnitude of the magnetic field. So what are all these things? Our maximum torque is 5.8 Newton meters. The number of coils is 1200. We have a surface area of 1.1 times 10 to the negative 2 meters squared, and the magnitude of our magnetic field is 0.20 teslas. Put all that in our calculator, and we see that the current going through this coil is going to be about 2.2 amps. And that is our answer.